Let's do an example figuring out if a function is even, odd, or neither by using a graphing utility. So I have three functions here, and I'm going to use the graphing utility Desmos. With Desmos pulled up, I'll go ahead and I've already entered in my functions here that I want to examine. Let's go ahead and turn this toggle to on and discuss this function. Is it even, odd, or neither? Well, let's check to see if it's even. So here's a point. It looks like this x value here, if we zoom in a little bit more, is a little less than 1. So if I reflect this about the y-axis, then I'm going to multiply the x value by -1, and I would get a point that's right here, and that's not on the original graph. And since it's not on the original graph, I immediately can determine that this function is not even. Is it odd? Well, let's see. If I take this point and I reflect it twice, first time about the x-axis, I would get to about here because the y value is a little bit less than 2. And so when I reflect it, I'll get something a little bit bigger than -2, and I reflect it again, and I get to a point that's on the graph. Let's take another point on the graph. It looks like this here is 1.5, 4. If I reflect that about the x-axis, I would get to -4, and then I reflect about the y, and I would get to -1.5. So that's also on the graph. In fact, if you reflected a number of points, you're going to see that you always end up on the graph of the original function. Let's go ahead and try a point that is on the left. So let's see, -1.5, -4. Well, for the same reasons that we just discussed, when we reflect this twice, we're going to first get to +1.5 as an x value and then +4 as a y value, which is on the graph of f of x. All of this leads to the conclusion that, well, the reflection, when you reflect about the x-axis than the y-axis, you obtain the original graph, which means that this function is an odd function. It is symmetric about the origin. Let's go to the next function, x² - 2. Is this function even, odd, or neither? I think it's a bit more straightforward to tell if a function is even. And that has to do with the fact that being symmetric about the y-axis is a bit more straightforward than being symmetric about the origin. So if I take any point here, for example, let's go to 2, 2, which is on the graph, and I reflect that about the y-axis, I get another point that's on the graph. And that's going to happen for every point that you choose. Because of that, we would say this function is symmetric about the y-axis, and thus this function x² - 2 would be even. Let's go to the next function, x² + x. Is this function even, odd, or neither? Well, let's go ahead and do some reflections and see if we end up with points on the graph. So at 1, 2, if I reflect about the y-axis, I get to -1, 2, and that's not on the graph. So this function is not even. It's not even because there's a point where if you reflect it, you end up with a point that's not on the graph. Is it odd? Well, let's take that same point 1, 2 and reflect it about the x-axis, which would bring us to 1, -2, and then about the y-axis, which would get us to -1, -2. We end up again at a point that's not on the graph of x² + x, and so this function is not going to be odd. Well, the conclusion from this is that this function would be neither even nor odd because it is not its own reflection about the y-axis, and it is not its own reflection when you reflect about the x-axis and then the y-axis.